Hello again, Stuart Box here from Sigma. Today we're going to talk about coatings and linings. I think it's appropriate when you talk about coatings and linings to start with the beginning of the process and work our way up to the final coat. So in all applications for coatings, a product should start at what's considered near white metal blast. You can see this small spot on this flange. This is a primer coat. We blasted off the primer to a near white metal blast. Suppliers of paint and paint systems will always encourage you to start with near white metal blast before you build up to the final coat. So when we talk about coatings, we categorize coatings into four broad categories. The first category is appearance, where the coating actually does very little in the way of protection. It just makes the product look like the customer wants it. The second category would be considered a barrier coating. And a barrier coating does just what the name implies. It provides a barrier around the product to prevent any sort of rusting or oxidation of any kind. Then there's a third category of coatings that are considered sacrificial. Sacrificial coating is where you have a metal compound in the coating that becomes, because of the galvanic reaction in certain types of environments, actually is consumed by the environment before the metal casting is consumed. That's why it's considered a sacrificial coating. It gives itself up to the environment that it's in. And then finally there's a fourth category where you have a combination of barrier and sacrificial. So we're going to talk a little bit more about each one of those specifically. So for fittings, in the category of cosmetic or appearance, we have two basic paints. One is black asphalt. This fitting is coated with a black asphalt material, and the other is a shop coat primer. Shop coat primer and black asphalt provide little or no protection to the base metal from the environment. They are there to get the material to the job, get it in the ground or installed with little or no rusting or oxidation occurring from just typical rain. So these coatings are not designed for long-term protection of the casting. For fittings, exterior coatings, there's a second type of coating, which is a barrier coating. And we typically have three types of barrier coatings. One is fusion bond epoxy, which is a dry spray, heat cured epoxy paint that is applied to the exterior of the fitting in such a way that it provides a very good barrier that's very tough, hard to break, and is one of the more sturdy barrier coatings that's available in the market. Another barrier coating is called Ceramawrap. It's also an epoxy, but it is not a heat cured dry spray. It's a wet spray. It is a product that's trademarked and sold by Enduron. There's also several brands of primer that would be considered barrier primers. They are two-part epoxy. The most common and the one that most all of our folks are familiar with is a Tnemec product, 140-1211. The 1211 is actually the color code. It's this same red primer color, but it's a two-part epoxy that's a very, very good barrier coating. It's designed to create a barrier, plus it's also designed as a primer so that a top coat can be applied in a particular application where someone is concerned about having different colors on top of top of their pipeline to identify certain processes. In waste treatment plants, you see certain pipes that are inflow and outflow being painted a different color. So we provide a barrier coating of the Tnemec 140 material in the 1211 color, and then a contractor at the job will paint the outside of that with a approved material that is the proper color or the appropriate color for whatever line they're dealing with. A third type of barrier coating that has become more prevalent recently in the United States is sacrificial coating. In Europe, they've had a standard for a zinc sacrificial coating for pipe and fittings for a number of years, and we've only recently seen it in the United States becoming more prevalent. We have a product that we're marketing as Sigma Zinc. That is a Tnemec zinc primer that meets the European standard for the number of grams of zinc per square meter, and then we cover it with black asphalt, and it would have zinc written on the side of it. I recommend you look at our webpage under fittings, linings, and coatings, and you'll see a brochure on Sigma Zinc. And finally, there's the combination of a sacrificial coating and a barrier top coat to give you the best of both worlds. And Sigma has developed a product that we're branding as Sigma Safe. This is an example of what a Sigma Safe fitting looks like. This is a standard fitting that has been coated with a Tnemec zinc primer that meets the European standard for the number of grams of zinc per square meter of the coated surface on the exterior. That primer is allowed to dry, and then we coat it with a barrier top coat of another Tnemec material that provides as good a protection as FBE. So this particular fitting placed in the ground in a very difficult environment next to a bare fitting with black asphalt, a fitting with zinc and black asphalt, or FBE would perform better over the life of the fitting in terms of loss of mass due to corrosion than any other product we offer. This is the best coating that Sigma can offer for difficult environments. It is a zinc Tnemec sacrificial primer with a top coat of Tnemec material that provides us barrier that is very, very comparable to FBE. So up to this point, we've talked about exterior coatings. The interior of fittings are also coated, but typically we don't call that a coating, although it is. We generally call the inside a lining. That goes back to the beginning of fittings, when the only type of coating that you could put on the inside of the fitting was cement. Cement is a coating. The coating forms a lining on the inside of the fitting. The reason that cement was initially introduced into ductile iron pipe and fittings is because clean water, even clean water, has minerals, and those minerals will actually cause a corrosion on the surface and a buildup. And so the cement protects the inside of the fitting from a corrosive buildup. And that sounds a little backwards, because typically when people think about corrosion, they think about something going away, almost evaporating. But with water inside of pipes, the minerals actually deposit as a result of corrosion. So the cement is the most common lining, which is, again, also a coating that we find on the inside of fittings. The reason that it doesn't look like cement is because we paint it with the same black asphalt NSF material that's on the outside of the fitting to control the rate of curing of the cement so that it doesn't crack. So the reason that a standard fitting is black outside and black inside is because we use an NSF approved black asphalt paint to control the curing rate of the cement, and it also is in this AWWA standard for the material to be used on the exterior coating as well. There's another group of epoxies that are used for exterior coatings and interior coatings, some of which are NSF approved for drinking water and some of which are not, and those that are not are typically used for sewer applications. So the list of those materials is probably most common is fusion bond epoxy, which is FBE. And FBE is again a dry spray that's heat cured. Forms an epoxy coating on the outside and an epoxy lining on the inside. It's good in most all applications. There's a group of ceramic epoxies that are available for the lining of the inside of a fitting or the coating of the inside of a fitting that start with one that we sell a lot of fittings using, which is Protecto 401. It's an Enduron product. Again, it's a ceramic epoxy. There's a material called Ceramapure, which is also a NSF approved material made by Enduron that is ceramic epoxy as well. Tnemec makes a product called 431 PermaShield, and Tnemec 431 PermaShield is again very similar. It's an epoxy resin material that ceramic epoxy resin that is applied to the inside of fittings to form a protective lining. There's Permox CTF in the same category. These coatings are all widely used in sewer applications because of their the nature of the ceramic epoxy does a great job of preventing corrosion from hydrogen sulfide gas, which is a byproduct of sewage. And finally, there's a material that maybe you might not think of as a coating, but it's certainly a lining and a coating, and that's actual glass. There's several processes that are available in the market where glass can actually be applied to the inside of the fitting. It's again a ceramic material. If you think about glass, it starts from silica, and ceramic pottery is silica based, so all of these products have a ceramic base, and they're just built up and applied in different ways. So we get a lot of questions on coatings for fittings, but we also get a lot of questions on coatings for our restraints. Coatings for restraints typically do not have the complexity that the coatings for fittings do, because the nature of the restraint is it's not exposed to the material that's being transported in the pipeline. So in the restraint, this is on the outside of all of the water, so what we have to be concerned with is the environment that the restraint finds itself in. So if it's outside, we have to protect it from rain. If it's buried in salt water, we have to protect it from salt water. So we have a standard coating and a hybrid coating called CoreSafe. The standard coating is an epoxy for all components, and the CoreSafe is another process that we haven't talked about that is also an epoxy process, but it's called E-coating. E-coating is an electrical charge applied to the casting that attracts the solids from a liquid bath of paint. It is widely used in the auto industry. Comes in various colors, but typically the most common is black. And E-coating provides a thin, very controllable thickness epoxy coating that you can then top coat if you choose to, and that's what we do for our CoreSafe. We use E-coating on all the components and then an epoxy top coat. It's this top coat happens to be blue, this top coat happens to be black, and if this were a PVC restraint, the coating would be red on top of the black E-coat. So E-coating, when you compare it to other types of coatings in a side-by-side salt spray test, which is the mechanism that is used to compare one coating to another, a little basics about salt spray. It tries to replicate a long period of time in a particular environment in a very short period of time by using aggressive combinations of both time and temperature and concentration of the material that is attacking or being aggressive on the surface. You take a small plate and you make your coating on top of the small plate, you cross hatch it, and over a series of hours you take the plate out and examine how the coating is being affected by the environment that it's in. So when we do side-by-side comparisons of our CoreSafe against the other materials that are available in the market, we find that our coating actually performs better because the likelihood of having a small defect in the coating on any process other than E-coating is very high. And that small defect creates a localized spot where corrosion happens very quickly. In an E-coated product, since it's in a bath of liquid and has an electrical charge applied to it, the only way to get any damage to the surface is for it to be struck or scratched, and that is very difficult with the type of E-coating material we use. It's very tough and scratch resistant. So that's kind of a primer on what we do to coat our restraints. The standard is epoxy, but the material is also available with E-coat and an epoxy top coat. Hi, it's Stuart and Laurie from Sigma, and we're here to discuss the video that you watched. So you had some questions about the information that I put on that video. So what do you got?
Well, on the coatings and linings, I was wondering, can we sell bare fittings with no coating or lining?
Sure, bare fittings can be sold. Typically customers don't like to get a bare fitting because it's got flash rust on the outside and they don't want to get a rusty product. But if all the fitting is going to have on it is black asphalt, there's not much protection that the black asphalt provides over the rust. So we just paint with black asphalt basically to make it look pretty.
Okay. How do we know what coating is appropriate?
We don't. That's not really our job. Our job is to provide the coating that the customer has requested. Most of the time, our customers are looking at a set of plans and specifications that an engineer has developed for a particular project, and that engineer will know about the specific coatings that are required for the area in the country or in a particular city where you might have stray voltage or aggressive soils and require special coatings. Or, depending on the application, sewer line will require a different coating than potable water line.
What is zinc and sacrificial coating?
Galvanization is a chemical concept where you have the process of metals corroding simply because of an electrical current that's induced between two dissimilar metals. So dissimilar metals might be ductile iron and steel bolts in a buried MJ fitting. Dissimilar metals could be the presence of a metal in the soil. It could be seen by the surrounding soil as dissimilar metals. So when there is the chemical term is when there is an electrolyte present that will allow electrical conductivity
sometimes corrosion happens at a much faster rate when there's not an electrolyte. And the zinc is more likely to give itself up than cast iron. It falls on the galvanic chart in a position where it would basically dissolve, if that's the best model that I can build for folks, is the zinc would dissolve into the soil, into the surrounding soil as the corrosion would take place, well before the cast iron would. So zinc coatings are sacrificial because they give themselves up. They sacrifice themselves
Okay.
rather than allowing the base metal, the ductile iron, to be given up in a process where chemical conductivity has created a situation where corrosion takes place.
Okay. Does Sigma have a facility that we use for coating and lining the different fittings that,
Sure.
require?
All of the Sigma facilities around the country have the capacity to coat. Not all facilities can coat all products. Also, some of the products that we discussed, some of the ceramic epoxies that we discussed, require special application equipment, which we typically don't keep or have, and those linings and coatings are, we buy those services. Some of those coatings are actually proprietary, and you have to have a license to apply them, and Sigma doesn't have a license to apply any of those proprietary coatings. So we go to someone who's an expert in those ceramic epoxies. The other coatings that we talked about with Sigma can apply. We only have one facility that can do FBE, but the rest of any of the liquid spray epoxies or the liquid black asphalt can be coated at any of our warehouses.
Which facility can do the FBE?
Alexander City, Alabama has a FBE facility that can handle up to a 4,000 pound fitting, pretty big, and all the way down to the small ones.
Well, great, thanks.
Okay.